Hello, my name is Harman Sindhu, and this is my project one, the unofficial guide. For this project, I built a RAG system which focused on Tacoma Computer Science and Systems professor reviews. The purpose of the project is to help students find information about professors based on student experience and reviews. I chose this domain because students often rely on unofficial information when deciding which professors to take. Universities provide like course descriptions, faculty pages, but they usually do not provide detailed information about teaching style, grading, workload, projects, or classroom experiences. And my goal was to make this information searchable through natural language questions. The system was built using 10 source documents containing professor reviews, student discussions, and UW-Tacoma CSS information. Before showing the demo, I'll briefly explain how the system works. So the first stage is a document ingestion. So I collected professor review data and student discussion information and stored it as text documents. The second stage is chunking. So those documents were split into chunks of 400 characters with a 100 character overlap. And the overlap helps preserve context when important information spans multiple chunks. So after chunking, I generated embeddings using the sentence transformer model, and these embeddings convert text into numerical vectors that capture semantic meaning. The embeddings were stored in ChromaDB, which acts as a vector database for retrieval. When a user asks a question, the system embeds the query, finds the most relevant chunks in ChromaDB, and passes those chunks to Grok's Llama model. The language model is instructed to answer only from the retrieved documents and not use outside knowledge. The system also displays source citations so users can see where the information came from. So for my first query, I will ask which professor is helpful outside our class. So the system retrieves review chunks discussing office hours, availability, responsiveness, and willingness to help students. And the generator response identifies professors such as Wes Lloyd and David Schussler as being supportive and available for assistance outside of class. The reason this query works well is because the retrieved chunks directly discuss the exact topic being asked about. The reviews contain specific statements about office hours, answered questions, and helping students succeed. The source citations were also visible in the response, allowing the user to verify where the information originated. And this is an example of strong retrieval because the retrieved chunks clearly match the intent of the question. So for my second query, I will ask which professor is a tough grader? So now the system retrieves reviews discussing grading standards, difficult assessments, and strict expectations. So the generating answer identifies David Schussler as a professor frequently described as a strict or demanding grader. And again, the answer is grounded in the review documents rather than general knowledge. And one thing I want to point out is that the retrieval stage is doing most of the important work here. The language model can only generate a good answer because the retrieval system found reviews specifically discussing grading practices. And the source citations displayed below, the answer helped demonstrate that the response came from the collected documents. Now for query three, I will say which professor uses project-based learning? And the generated answer references professors such as Tom Kapal, and the system retrieved chunks about quarter-long projects, team assignments, and project-focused coursework. So this query, in my opinion, it demonstrates one of the advantages of retrieval. So the reviews do not always use the exact phrase project-based learning, but the embedding model is able to connect related concepts such as group projects, quarter-long projects, and even hands-on assignments. And this sort of allows the system to answer questions, even when the wording used by the user differs from the wording used in the documents. And now I want to discuss a failure case, which is which professors are described as having a heavy workload. And although the system returned related information, many of the retrieved chunks, course difficulty, grading rigor, or challenging coursework instead of workload specifically. And during testing, many of the retrieval scores for this query were significantly higher than many successful queries, indicating weaker matches. And if I were to continue this project, I would collect additional reviews that discuss workload more directly and experiment with alternative embedding models to improve retrieval quality. And this failure case helped me understand how strongly retrieval quality affects overall RAG system performance. And now for my evaluation report, I did create 5 test questions before implementation. 4 of the 5 questions produced relevant retrieval results and accurate responses. The questions above about help for professors, grade difficulty, project-based learning, and teaching enthusiasm all performed well. However, the workload question was only partially successful and became my documented failure case. And one important lesson from this evaluation is that even a well-designed retrieval pipeline depends heavily on the quality and coverage of the underlying documents. So overall, the evaluations show that the system works well for professor-specific questions that are well represented in the review documents.